to feed yourself or your family, that's like less elastic.
Yeah, that's probably true.
Leisure.
Yeah, so he claims that this is why we talk about intent. Like if you look at sociologists, they're often thinking about stuff that doesn't involve transfers. And so they talk a lot about intentions and what did this person mean to do. When we think about moral sanctions, we think a lot about intentions. And intentions are basically just a notion of elasticity. You intended to do something if you were elastic to the punishment that thing would do. And it was sort of like it wasn't intentional if you weren't elastic to various things. So that's how Becker defines intentions. And he thinks we think about intentions in situations when we have this costly punishment. When we have a free punishment, we don't think about intentions. And that's why economists don't think that much about intentions, but maybe sociologists and moral philosophers think about intentions a lot. Yeah, go ahead, Chrissy.
So what about like kleptomaniacs? I mean, in some way they do intend to like steal, or I mean, I guess you could take it to another extreme.
Yeah.
Think about serial killers to some extent. Before these people are caught and possibly removed from society.
Yeah.
You could say that they're planning things out, but on the other hand, maybe there's a sickness that's preventing them from.
Well, I mean, I think our usual reaction to those people is exactly in line with what Becker would say, which is that we should probably get them off the streets, but we probably shouldn't punish them necessarily. Like we should try to treat them, right? Okay, yeah, Gantara.
I have one question. So, I think Becker also mentioned about the difficulty of measuring elasticity of these criminals.
Yeah.
And I think, if I remember correctly, but I forgot the logic, but so the reason why it's better is also because you don't have to know exactly the elasticity.
That's true. That's another good point. That's right. Okay, so the reason that elasticity matters here is that it's wasteful to punish, right? Otherwise, we would just set the punishment equal to the harm that was caused, and that would offset things, right? But IP is very similar to this, but sort of in reverse. So how is IP similar to this in reverse, Chrissy?
So you have people acting in a risk-averse way as far as their incentives are known. So they could be very price elastic to creating if they see what their potential profits would be. Some people may be more incentivized the more their expected profits, whereas other people will invent regardless of what their expected profits are. So there's where the elasticities would match up and incentivize the more elastic people.
Yeah, that's right. But the sort of key fundamental point is that IP is a case where things are a beneficial activity, which is costly to reward. Why is it costly to reward? Well, if we could just give people prizes, then it wouldn't be costly to reward. That would just be a transfer. But if we have to reward them with market power, we know that causes a static distortion, right? And as a result, and in fact, that's true that IP creates a beneficial externality, even if we give the person the full monopoly profit, because there's still some inframarginal consumer surplus, right? But rewarding via market power is wasteful, and therefore we have to think about the elasticity of innovation with respect to the reward in order to determine the optimal level. If we could just give out prizes, we would just say, well, we'll give you a prize, and we won't worry about what the elasticity is. So remember in the conversation I was having with Daiichi, he was claiming, well, the elasticity is not very high, therefore we probably shouldn't have so much intellectual property. And that's relevant only to the extent that it's costly to reward using intellectual property, which it is because of the static distortion. So that means that in reverse, the theory of optimal intellectual property is very closely related to Becker's theory of optimal criminal enforcement. Yeah?
But here you only consider the costs to be the daily loss, but also there's other costs of rewarding with IP.
Yeah.
Like firms are fighting each other over products, and when some firm has some product that is similar to the other one, they go and argue and waste a lot of money.
Yeah, I mean, there's a lot of administrative costs of the IP system in practice. Now, I'm thinking of IP in a broad enough sense that that applies only to some of the forms of IP that I'm talking about. Like the authenticity IP and the trade secrets IP, it won't apply. But there will be other potential costs like associated with those. Like for keeping a trade secret, you have to like enforce secrecy within your company, and that might be costly, you know. So, but the basic intuition is that we should have greater protection for IP if the supply of innovations are more elastic to monetary rewards, if the social benefits of innovations are large relative to the rewards that we give, and if the deadweight loss created by giving a bit more protection is small. And that's exactly the same comparative statics that came out of Becker's model, and we'll derive those out of an IP model, right? So the basic trade-off in IP is the incentives provided by IP versus the ex post distortions. The more IP protection we have, the more deadweight loss we have, but we'll also have more innovation, right? And the first unit of protection that we give doesn't cause much deadweight loss, because remember, as we just start to elevate price a little bit above costs, that doesn't really create any deadweight loss because it's a triangle, right? But on the other hand, as we get towards the maximum of profits, right, then profits are like close to being optimal. So there's like only a little bit of a triangle from a little bit of reduction in IP protection below full monopoly price, right? And on the other hand, the change in deadweight loss could be substantial. So we're never going to want to have full monopoly, and we're never going to want to have marginal cost pricing. We're always going to want to do something that's in between the two. So optimal protection is always marginal. The question is how much protection we want to give, and that depends on the costs and benefits. So the costs are the deadweight loss of consumption and a deadweight loss, which is sort of related to what Mohammed was talking about, from follow-on innovations, because they might find it harder to make profits if there's already this IP protection of things that they're building on, because the pre-existing person will get some of those profits, right? And the benefits are the incentives to innovate, and also, in the case of some forms of IP, the incentive to disclose information about your product. So if you have to keep a trade secret, right, then you often won't tell anyone about the value of your product or about the information about your product. If you have IP, then you feel safe to disclose that. Okay. So to give you a little bit of empirical evidence on each of these, Cockburn and co-authors in 2011, looked at evidence on the incentive effects of IP. So they compared countries that had strong and long IP protection to countries that had either short or weak IP protection. And he looked at how likely a firm was to introduce a new drug that catered to that market, right? Or in particular, he looked at cases when a firm had created a drug and it was just a question of when they entered that market. And if there was strong and long protection, he found that the hazard rate of them entering was much higher than if they had short or weak protection. Okay. On the other hand, Heidi Williams looked at the effect on follow-on innovation. So she looked at the race between Celera and the government I don't know if you guys remember this in the Human Genome Project, that Celera was a private company that every time they discovered a gene would patent it, and the government put everything into the public domain. And what Heidi found is that the number of publications based on genes that the government found was significantly higher than the number based on Celera ones, and discoveries of medical uses of those things were much higher for the government ones than for the private ones, because Celera wasn't going to take a chunk out of the profits that you made on that thing. Okay. So let's focus on the consumption distortion versus the incentives effect and leave out the other two parts, right? Each innovation creates a new, let's consider a model where each innovation creates a market for a new product. And products have no marginal cost of production. And the idea behind that is that most intellectual goods are essentially free to copy. And let's assume that all products once created will have the same demand for them, Q of P. And let's normalize this so that the quantity when the price is 0 is 1, and the monopoly's optimal price is 1. Consumer surplus is going to be the integral, given the price that's being charged, from that to infinity. Now, the price we can think of as basically being the fraction of the monopoly optimal price that's being charged, right, if it's less than 1. So if the firm earns profits pi, which are P times Q of P, and I'm going to assume that innovations are costly to produce. Kentaro, why would innovations be costly to produce?
Of course, you need a lot of research and development, and that also requires focus of time and capital.
Yeah.
It's just very expensive.
Yeah. And in particular, it may be that every given attempt to make an innovation only succeeds with a very low probability. And so the expected cost to produce like one innovation might be much larger than the amount of time that it took to produce any given product because of the uncertainty, right? So that creates a supply of innovations, which depends on the profit that is earned on any given innovation. OK. So Kentaro, what is going to be total welfare for the consumers plus the producers in this market?
So what do you mean total welfare?
Yeah. What's an expression for total welfare?
It should be producer surplus. Okay, so the profits they make after they innovate, plus consumer surplus gain from it, and minus production cost.
Yep.
And maybe minus deadweight cost. But I'm not sure because
No, not.
if they create a new market, then
It-
will not be deadweight loss.
Yeah, so that's what Kentaro said was right, but there's a particularly elegant way to express this. So we can just say that it's the consumer surplus, because that's the benefit the consumers get, times the supply of innovations, the number of innovations that are created, plus the producer surplus, which we can just measure from producer surplus rather than having the profits minus the cost, because the supply function captures all that stuff by the envelope theorem, right? OK. So if we now take the first order condition of this, Eric, what are we going to get? If we take the derivative of this with respect to price. And let's think of price as being basically the level of intellectual property protection. The more intellectual property protection, the greater fraction of the monopoly price you're able to charge.
Can I just write it?
Yeah, please.
So you're taking that price on both sides. So on the left side, I'll just do the
Yeah.
this S of I of P times this is big CS plus byproduct rule. Oh wait.
Yeah.
Right, and so what this is chain rule. And then the right-hand side is the whatever theorem of something.
Leibniz?
Yeah. S of just pi of P, right?
Yeah.
And this just has to equal 0, right?
You missed times pi prime, right?
Oh, right.
Because
Right.
that's equal to 0.